Hello to everyone and welcome to Mechanical Engineering Virtual Meetup. It's our July session with the special topic of the month, product visualization. My name is Anton Fedoseev. I'm the content strategist at Autodesk and the host of this series. Today we have 4 speakers and my co-host Michelle Rasmussen. So we'll introduce the speakers as we go, right? But before we jump into the presentation and into conversation about visualization, let me remind you about the basics of how we run these webinars. So first of all the lines are muted to reduce the background noise, but you can use Q&A panel to ask questions at any time. In fact, since it's live session, we highly encourage you to ask as many questions as you can, right? Then we will send you the recorded session in a couple of days after the webinar. And also all of the questions that we will not be able to answer, we will drop them on the forums. So you will have the link to the forum in the chat window. So this is the way it works. So stay active, ask questions at any point of time, and we'll try to answer as many as we can. So what is mechanical engineering meetups? It's our way to informally connect and talk about different solutions that are already available to you. We're not trying to sell anything. So this is more kind of educational series about what's available. We invite different speakers to talk about their experiences. And also one of the goals to actually build a kind of sense of community of mechanical engineers and people in this profession. We have a couple of other series. In this case, it's generative design for manufacturing, where we talk completely just about generative design in similar format, but the focus is 100% generative design. And also we have 6 other series focused on other roles in CAD industry, such as architect, BIM manager, civil engineer, but they all work in a similar format. Okay, with that, I'd like to give the stage to Tom Tremblay. Tom, let me transfer the control in just 1 second.
All right, are you able to see my screen?
Yes, we can.
Great, great. What I'm here to do today is to talk about a new course that's going to be coming along, or a course that's currently available up on the customer success portal on visualizing and animating your product design. So the course itself has multiple, excuse me a second. The course itself is going to be focused on visualization options for Inventor and getting that information into other applications such as 3ds Max. When it comes to Inventor itself, you have a lot of rendering options. We'll cover and touch base on a number of those, both with the real-time ray tracing directly in the CAD model, as well as the ability to use Inventor Studio to do more advanced rendering functionality. We'll apply lights, apply cameras, then create an animation, render that animation, and then we'll also have an exercise on simplifying a model for people to use 3ds Max to create virtual reality presentations. The course content gives an overview of the workflow and tools. There are videos of each step in the process, as well as step-by-step instructions so that you can follow along and work through what was displayed in the video. The Inventor data sets are also available to you so that you're working with the actual data that was in the course rather than having to try and find some of your own data to work with. And there are quizzes incorporated into the course that will test your learning along the way. The learning path itself is 6 different courses. The first one is just a quick visualization inside of Inventor. A lot of times people are able to create really compelling visualizations to share with others to help communicate the concept of a design without even having to go into the Inventor Studio. The next phase is creating an animation of your product, then animating the assembly for service instructions, for creating an exploded view of the animation to help people understand how things are put together or how they need to be serviced. Then, as I mentioned, will look at the process of taking a very complex mechanism, a very complex assembly, and simplifying it so the critical elements are available to be brought through 3ds Max into a VR environment. And I think we'll be speaking a little more in detail to those last three courses or the last three elements a little later in this broadcast. What I want to talk about is just showing you a couple of examples from the course. And the first one, we'll talk a little bit about rendering in Inventor. As I mentioned before, you have the ability to do a quick visualization. You can get into the detailed lighting, create up multiple cameras and use those cameras to modify the not just the perspective of the view, but even do things like add depth of field to be able to give a more realistic image on the screen. You can change your ray trace quality levels. And of course, we can generate rendered image files in PNG, TIFF, GIF, all the standard formats. In the course itself, we'll just do a little bit of a sample of the video that is with the course. This is starting part way through. This is setting up a camera or making modifications to a camera. We're able to easily use grips to modify the position of the camera itself. The rectangle that you see is the field of view. You can change the zoom element of the camera. So you're controlling what is seen by the camera itself. You can enable depth of field. As I mentioned, the objects nearer to you or based on that distance from the camera will be clear, and objects falling farther away will start to blur. We also have some really great capabilities for making and modifying cameras. So here we see the camera view that we had. So we're able to go back and quickly make modifications. We also have the option of just simply setting a new point of view. And then when we find a point of view that we like, we can make sure that we're in perspective view. And then we can just simply generate a camera or create a camera from that view. So rather than going through the more manual process of setting up a camera and a target, we can just simply set a view and build from it. Then in the rendering environment, we can establish what camera we want to base a rendering on. We can set up what the values will be as far as resolution. We can go with the current display window resolution or set up a standard resolution. We can change the lighting style. So even though we might be working in a certain lighting style and ray tracing in the visual field would work off of that, in the rendering environment, we can change what lighting is being applied. We can establish how we want to output that rendering, and then we can start getting into the more detailed elements of the renderer itself, setting values for it. For example, we can set up the rendering to just run a certain amount of time. We can set up rendering by iteration. So we can say that improve with each iteration, the visual elements of the rendering will improve. So we can set a number of iterations to run through, or we can say until satisfactory. So we can watch the iterations develop, watch the quality of the image improve, and then at the point where we think it's sufficient, we can stop it and export that image. Here we'll just set a number of renderings, number of iterations, and start the render. And you can see what that looks like as each iteration is developed. You can see the iteration count in the lower left of that dialog. And it will continue on until it gets all 50 iterations. So that's an example of one of the courses. Another one is animation in Inventor. In Inventor, you can animate just about everything from the degrees of freedom of an assembly to a component's visibility. You can animate what current view you have of the assembly, and you can generate animation files. And here again is an example of one of the videos from the course where we're able to animate a turntable of a camera. So animating the transition of the camera around our assembly. So if we play the assembly, we can see the transition of the camera moving around it. Okay. Now that we see how the camera is going to sweep, we can go and change what we're viewing in the timeline, which is in this case the camera. This time when we play, we'll follow the camera and we'll see the change from the camera's point of view. So we're able to develop these animations and these renderings using a timeline, something that would be very familiar for someone who has used tools like 3D Studio Max, and develop really intricate capabilities. We're also able to do things like animate positional representations. For those of you using Inventor to make complex mechanisms, you know that a lot of components can be moving just to affect what appears to be a simple change in the position of the assembly. Positional representations can be used for a number of things, including creating, alternate drawing views. But here we're going to say we're going to transition from one positional representation to another. We can change the acceleration or deceleration of that view if we need to give a more realistic spin up and wind down feel to the animation. And it will just simply transition from one positional representation to another over that value of time. As we play it in the preview, it's a little tough to see, especially with the rotating camera, but the gears are spinning against each other. Once we have everything down, we can start to generate a rendered animation, and we'll be able to see what the final results are. I'm just going to accelerate this just a little bit. Here it's rendering iterations for each frame of the video. So not just outputting a simple video, but outputting a rendered video. And let's just see what that final result looks like. Okay, that's the preview of the final result, but the actual final result looked like this. And this will run a couple of times. You'll see how the assembly fades out, and you can see the gear train spinning down. So that is included in that course. That will take you through the entire process. Then there's another one of the chapters in that course is on assembly instructions. How to separate your assembly and capture snapshots of the process, and then to export images and animations from it. And you can create multiple storyboards so that you can create from the same assembly, you can create assembly instructions for more than one segment or more than one portion of your design. We'll just go through this a little quickly. This is again starting well into the video. You can see the timeline at the bottom. The blocks that have the crossed arrows represent actions happening to components. You'll see the cameras. Here we've just captured a new camera for this point of view so that at around 6.5 seconds, we have this new camera. So we can see how each time the timeline passes over a camera view, it transitions what that view is. The ending view isn't quite what we want. So if we move the playhead over it and then zoom out, we can recapture that camera and reestablish, keeping the same timing. So we see it as spread apart, we change views and then change back. So it's very easy to start developing these more complex animations of how the assembly works. And you can always capture any of those views, save them out to a snapshot, and then you can publish those snapshots out to rendered views, or you can publish the animation out to video files that can be shared with others so that they're able to see everything that you are doing. Of course, here we're just setting up some quality. Let's skip to the end to see a little bit of an example of some of the output that you can create. Oh, I think that was it. All right. One other thing that we wanted to quickly touch on, and we'll get into more detail in rendering with Fusion with Paul, is a course that we're going to be developing here shortly, is taking a look at interoperability between Inventor and Fusion 360, and a portion of that will be on rendering. So just wanted to speak, I don't want to take too much of Paul's time or too many of his focal points, but Fusion 360 in and of itself has some tremendous rendering capabilities. It's not designed to go to the nth degree in certain ways that Inventor can, but for a lot of people, they can get highly effective visualizations without all that overhead. And of all the capabilities of Fusion 360 rendering, the one I want to focus on is the ability for the AnyCAD functionality in Fusion 360 to be able to link Inventor data as well as other data from other systems into it, so that if you have an engineering environment that is using Inventor, focused on developing the design with Inventor, but you don't want your engineers taking time to create renderings, or you don't want your marketing people or publications people uh, using full Inventor seats, or having to deal with the complexity of the interface that Inventor has because of its power, you can use a tool like Fusion 360. And just to give a quick idea of how that would work, and again, this will be a course coming down the line, is here we have an Inventor IPT file linked into the Fusion 360 Team Hub project and the assembly. We'll open up the assembly as well. And I'll be skipping through some of this. You'll see that you have the ability to move through the browser to turn components off and on. And what's great about this is you've linked Inventor data in. So you're not actually editing the live Inventor data, but you're able to do things like make modifications to how that data looks. You're able to do things like change what your point of view is to make a different portion the top to help with the image-based lighting without affecting the original Inventor data, but still having the ability to benefit from the Inventor data. I'll skip forward here a little bit. We're able to take all of the different appearances overrides and update them over the original Inventor, then customize them. So the person who needs to create the visualization can get the exact feel that they want, including being able to go into color libraries and use Pantone finishes. Moving over to the render workspace inside of Fusion 360, you'll see there's really only about 8 tools that they have to work with. The image-based lighting extracts its lighting directly from a hemispherical image that's around it. They can quickly change what that image is. Here we'll drop our gear cover out into the middle of a crossroads in the desert. But one thing that's great about this is you get that natural lighting, but coming back to the settings, not only can you change the position of the component in that lighting, but you don't have to use all that background in the image itself. You can simply go back to a solid color. So let me skip ahead here, because I'm sure Paul will be showing you some of the rendering capabilities, and there's tremendous rendering capabilities. But let's pause for a moment. Now back in Inventor, we're able to go in and make a modification. And this is where the power really comes in, is once the person who needs to create the rendering in Fusion 360 has their work done, any change that's made by the engineering staff to the design itself, we'll pop back over to Fusion here. And we can take a look at what our finished rendering looks like. All right, then let's go back to our assembly. And in the upper left corner, we now see that a link needs updating. That icon probably looks familiar from many of the other Autodesk tools that can link data from other sources. Once we update the file, it only takes a second, and you'll see that now the updated base plate has been included in this assembly. So the person can go back into their rendering, keep all of the lighting that modifications they had made, keep all of the other changes they made, and just simply update the image that they needed to generate. Well, that's really what I wanted to touch base on. Of course, you can take a look at the visualization course, and just keep an eye out for this course focused on the interoperability with Inventor and Fusion 360.
Well, and this is great, Tom, because very often we tend to use Inventor as a just mostly design tool, but in fact it can be used, and it has pretty powerful both like rendering and animation capabilities and assembly instructions, and a lot of the things can be done in Inventor. So thanks for the reminder. And again, we'll drop a link in the chat with the course, and also you'll get an email with the information where you can learn what Tom demonstrated today. But I'd like to move to the next stage to kind of talk about two other things, right? What can we do in Fusion 360, and then also talk about some additional visualization capabilities with 3ds Max, but we will still stay within mechanical design domain, so we're not going to talk about animation and media and entertainment industry. So next speaker it's a pleasure for me to have Paul Sohi today. Paul, so let me make you a presenter. Okay, we can see your screen. Paul, why don't you introduce your new exciting role and say a couple of words about you?
Sure, absolutely. Hello, everyone, and good morning. My name is Paul Sohi. I am our content marketing strategist on the Fusion 360 side. Previously was one of the Fusion 360 evangelists. I have arguably one of what I'd like to say one of the funnest roles at Autodesk, where I get to collaborate with a lot of our users and help them bring and make the greatest, latest products out on the market. Today, what I'd like to do is expand on what Tom just shared and teed me up so nicely for, and dig a little deeper into how you can use Fusion 360 to visualize, and show you a couple different ways that you can leverage the rendering environment. What I'd like to also add is that because there's a lot of parity between Inventor and Fusion 360, especially around the animation space and the visualization space, on a personal level, I find that this creates a really great opportunity for workflow, where if I'm kind of in the zone on one of them, there's no need for me to jump to the next one until it's a specific feature that I'm going to be using. So with that in mind, I'm going to show you two different ways you can make the most out of visualizing and rendering with Fusion 360. So I'm going to jump over here to our render environment and start off by letting my laptop load. Just give that a minute. So this is more a testament to my tired old laptop than it is anything else. So what I've done here with this render is I've set up a few things. With all the textures, you have options to edit and change them a little bit. I've used some basic primary colors here. And you can see with things like the plastics, we have the ability to, of course, like change the color. You can use a color library, so if you happen to have a Pantone chart handy, you can reference that and then pick the specific color here. But you can also make changes to the roughness of the ABS plastic, in this case, the acrylic plastics and the reflectance. But if you go into the advanced settings, you have a lot of options to expand this upon. So if you'd like to add, for example, a textured surface to the plastic itself, you can do so with a bump map. You can also create cutouts to show transparency of light. And you can see as soon as you click on that, it's going to ask you for what file you like to use. And you can also create translucency and emissivity with all the materials. So there are a lot of options here to expand the basic texture library to start to tease out more accurate representations of the kind of work that you're doing. So in this case, we have a file that's it's a mechanical keyboard made, of course, of a PCB, some switches which use plastic, a metal plate, and then some ABS keycaps. So when it comes to rendering it, I've set up a few things here. So of course, we've gone through the textures, and next in the scene settings for the environment library, because I'd like to create a render that really makes the whole thing pop. First of all, I've exploded everything out just for that additional layer of wow factor. But I've started to tweak a few of the basic functions here. So we can play with our focal length, for example, to make the angle more dynamic or more kind of orthographic, going from 35 to 90. This works just in the same way that it would if you're using camera lenses with any kind of interchangeable camera. You can also change the exposure, and the exposure is going to affect things like bokeh, as well as the actual exposure in terms of how bright or dark the render comes out. So you can see what that's doing there as I slide that back and forth. So we'll put that back in. You also have an ability to add a depth of field. So if you want to add an element of blur and to your render, there's no need to do that in a tool outside of Fusion. You can do it right here. And it works via an integer, which is quite handy. So instead of having to do the maths in your head of figuring out what apertures would yield certain bokeh effects based on the other elements that are going on, like the light in your render, you can simply set an integer of maximum blur to minimal blur, and with cloud rendering and with an in-canvas render, very quickly see how that impacts things on the fly. Next up, there's of course the aspect ratio, which can be quite important, especially if you're doing an in-canvas render or you're doing a local render. You're going to want to bind that in some capacity. Now, I typically use these settings all the time, and so what I've done is I just hit this button right here and I save it as a default, meaning that every time I come into this space, I don't have to set any of those scene settings up again. My default is ready to go. And we talked briefly earlier on about the current environment and the environment lighting and how that impacts things. What's really cool about that, though, is that you can also provide your own HDRs, either by creating them using a 360 camera or downloading and using any included one. So for this render, what I've gone and set up is a sharp highlight environment. I've switched my color to a solid color and I'm using a black background. I do have a ground plane on, in fact, so there is a small amount of shadow casting over here that will happen. And then really the only next step is to just sort of pick the angle I like the most. Sometimes you may want to save it. So up here in the top left corner, you can see you have named views, and I can right click on this one as soon as I close that down. Excuse me. And hit new named view. And now that view is saved. So should I pan away from this or move it away, as soon as I click to that, it's going to bring everything back to that set view. From here, I've got a couple of options for rendering. I can do an in-canvas render, which is going to use my processing, and it's going to happen in view, and will take up the activity that Fusion 360 is doing. So at this stage, you'll see it's starting to load it in, and the render will begin. We have an elapsed time down here letting us know how long the render has been running through, what iteration of the render it's at, and then you also have the ability to set whether you want it to stop at an excellent quality, a final rendering quality, or run to infinite. But of course, by setting it to run to infinite, it will do exactly that and just keep going forever until you have the render as you want it. From there, the other options you have is to hit the render tab, and now you can render either locally in the background, so it will operate as a process and inform you when the render is complete, not requiring you to just sit and wait for it to be done. And of course, you can render it in the cloud as well. From here, you have additional options such as additional ratios that you may want to work with. So if we jump over to print, you'll see that you have the options are switched to a print size as well as the PPI that the image will be produced at. Of course, in custom, you can do all of this and tweak these. So you can see it's carried over what I'd selected in the print menu. And if I open this up and switch to 16:9, it's now switched to a custom ratio, and it's simply adjusted what was there already. So this really helps you set things up really, really quickly. One of the other ways that you can work with rendering in Fusion 360 is actually to create custom lighting. So in this example, what I've done is in the modeling environment, I've treated the model space like a photo studio. So I've included 2 light bars here. These are set to neons, and behind them are these mirrored arcs. So these are designed to bounce the light back in, just like you would see in a regular photo studio. So when I switch over to the render environment, to take advantage of this, you can see that everything is pitched out. If I go to my scene settings, all I've done is I've set the actual environment brightness to 0. So if I pull this up for a second, you can see all our objects are here. But the environment here in Lux is actually the lighting that's coming from that HDR image that we discussed earlier on. So what I would want to do for this kind of render, which is really designed to sort of tease the product that I'm working on, I've applied these two lights. I've set a material that's reflective so that only really edges are going to be pulled out. And when I set the render to a brightness of 0 and hit play, you'll see that the only thing that's going to manifest are the highlighted areas where the light is casting onto the object. This helps me to create a really dynamic and poppy image that pulls the attention of someone that I want to look at it without giving away too much of the detail. Now, what's really handy about this is that when I'm in an in-canvas render, I can still open up my appearance library and tweak the lighting. So to me, it looks like the blue is kind of coming in a little too bright. So all I have to do is right-click on my LED here, and you'll see that compared to earlier on with the plastics, where luminance was not included as one of the base settings, because this texture is, of course, emissive, luminance is going to be present and available to you by default. So in here, all I have to do is drop that down. So if I drop that by 2000 lumens, you can already see that the light is a little less pronounced and it looks more like what I want. If I want to tweak the color, what's important to note is that there is a difference between the appearance of the texture, which is what you're seeing here, and the actual light that's being cast. This is probably best thought of as the difference between a coating that you can put on glass and the actual color of the filament that might be lighting the environment up. So in this case, the filter color, which is what is changing the actual casting of the light, is slightly different to the actual appearance of the object itself. This is not intentional, but well, it's intentional in the respect to highlight the differences, but it's also important to note that for the sake of the render, the only color that's going to make a difference here is the filter color itself, and of course, the strength of the color. So hopefully that gives you an insight into some of the more advanced and deeper ways that you can use the visualization space in Fusion 360. And of course, when you run these renders and you do them in the cloud, you will see all of them down here in the gallery ready to roll. Thank you.
Well, huge thanks for this demonstration. Of course, we've got a couple of questions, so that since you're leaving the webinar, I wanted to ask right now. So if you don't mind, could you talk a little bit about the kind of the rotating table kind of functionality and also the scenes, right? So how to put a model in the context, any recommendations or best practices for this?
Oh, absolutely. So let's stop this render and we'll switch over to the mechanical keyboard. So when it comes to environment rendering, what you're going to want to focus on is operations of scale. And what that really means is ensuring that the environment that you use is proportional to what you're doing. Now, sometimes this can be a little jarring for those of us who are empirically inclined because it requires us to really just eyeball things. So for example, if I drop this into a plaza environment, and we'll just wait for that to load in, I will switch my settings here from a solid to an environment. And you'll see that as I pan this around, there are a few things here that don't make a ton of sense. So it already looks as though this is massive in comparison to the stone on the floor. And well, one way to fix this would be to simply just zoom it. But obviously, that's not ideal. You'll end up with something that's far too small and maybe not all that usable. So what we'll do instead is load up our position here. So with position, we can first change where the height of where our object is sat relative to the ground plane. And if we put this on 0, you'll see that it's grabbed basically where it is in the environment, in the design space relative to the render space. So I'm going to pull that up. And then next, what I'm going to want to do is apply flatten ground. So what flatten ground does over here is it will pull the ground plane to be to the object and now give me an option to change the ground scale. So with ground scale, I can start to make this look a little bit more realistic. So as I tweak this, I'm going to pull that until it's proportional to a keyboard. So it's about there. Cobblestones are, the way that I think of it is each one of those cobblestones is sort of about the size of a hamburger. I know what a hamburger is in my head, and that's how I will gauge that. So with that set, I can now render that, and the object will look more realistic relative to the space that it's sat in. Of course, examples where you would really apply this would be things like if you're working with cars, for example, and you have an HDR of the road scene, you will really want to pay attention to applying a flattened ground and a ground scale to ensure that the vehicle is proportional to the road that it's sat on. Hopefully that answers the question.
Yeah, it does. And like kind of to build upon this, is there an easy way to add your own environments?
Absolutely. So in the environment library, if you hit attach custom environment, this will open up a dialog box asking you for the file. All you need is any HDR. So you can find HDRs free online. There are plenty of libraries out there with environment DOMs that you can pull in. You can also produce them and edit them in Photoshop. So if you grab an HDR that you'd like to use, but the lighting is not all that great, the lighting is actually sourced from the white and the black areas of the HDR itself. So you can see in the thumbnail here that we have a 360 panoramic view of our environment, in this case the plaza, and there's a very bright area here, which is where the sun is, and that's actually where the light is hitting and is cast from. If I rotate this, you'll see how that light impacts it. So it's brightest there, meaning that as I tilt it around, you'll see that that's basically where the sun is. Yeah, so it's brightest on the back now there, based on that data. You can also produce HDRs with a 360 camera, which are quite affordable and enable you to take any environment that you might come across and use as a render space in Fusion 360 also.
Okay, that's great, Paul. Huge thanks for joining us today and demonstrating all of these incredible capabilities in Fusion 360. So I know that you need to go, so thanks for staying longer. And we're having our next speaker, so let me give the stage to Ben Bisaris, and Ben will talk about how to kind of try to do something else with those mechanical models and see what 3ds Max can offer. So let me give the stage to Ben in just 1 second.
Okay, so hello everyone. My name is Ben Bisaris, and today I'm going to be talking about a course that I created in conjunction with Anil, which is basically how to take your designs in Inventor or even Fusion and then bring them into VR using 3ds Max and 3ds Max Interactive. Just a little bit on my side. So I'm a technical support specialist at Autodesk. Focusing mainly on media and entertainment, but in the more recent years, I've kind of branched out. I've always been a bit of a generalist. With 3ds Max, it is used quite a bit in also the AEC and product design industry generally for rendering. And that kind of got my interest into doing other things. And then as a hobby, I like to build things. So I got into CNC, 3D printing, laser cutting, all of those kind of things. So because of time, let's get straight into it. So the course that we created was basically how to bring, like I said, Inventor into virtual reality. And really this course, in my mind, I wanted this course to show the value of virtual reality. So one thing that I found interesting is that both VR and consumer 3D printing had a parallel rise and fall in the public's eye, I would say. They both, when they kind of came onto the scene, they exploded and people were essentially, I would say, overhyping what they can do. So people were thinking that, for example, with VR, it would turn the way that we interact with our computers. into something like what we see in Minority Report, or for 3D printing, it would be like the replicator in Star Trek, where all we would do is just choose an item on the screen and, out it would pop from the printer. And I mean, maybe that's possible in the future, but as it is right now, I think we all know that that really isn't the way that it's used. So although the hype has died down, really, I think now we're beginning to see more and more the true usefulness of these products or these workflows, essentially, as essentially you really need to think of it as an extremely useful tool in our tool belts. So it's not going to replace anything. It's just another tool. So you only really have to look at the architecture and automotive industry to really see what's being done with VR and to see where it could be leading in the future. So one of the things that I find very useful for VR is basically how we can use it to help design our products when it comes to the human machine interface. So a lot of times we'll design a product and only after we make the parts. So this is an example, I think, if anyone who builds things has probably encountered this before. You design a part, you make or let's say we design an entire machine. And then once we build the parts, we find, well, we actually can't put it together because either there's areas that we can't access, or the tools doesn't fit, and that requires that we just have to start over again. So it's a lot of time lost. Also, ergonomics is something that's extremely important that we can't ignore. So that is what the automotive industry is using VR for. So they use VR to build a mock-up of their design to see whether or not things like controls are easily found. Can they interact with them easily and also in a logical way? And also to see if sight lines are clear. Are there things blocking it? Are pillars in the way of areas that normally someone would be actually looking in? Excuse me. And the other thing is also in terms of actually presenting your idea, your concept to others. So especially when it comes to complex designs, it may be hard for others to actually understand the value of the design that you've made. And as they say, a picture's worth 1,000 words. So, if you can actually have the person interact with it virtually, basically the usefulness of that is through the roof. So, even things like blueprints or drawings or renders may not make it as easy as possible or as clear as it is in your own head. So the course itself is broken up into 3 parts. So taking what you have from Inventor into 3ds Max, and then in 3ds Max, you're going to see how to prepare it for 3ds Max Interactive. So 3ds Max Interactive is a feature of 3ds Max. So it's a separate program, but it does come with 3ds Max. And essentially it's a game engine. And that is what is used these days to create not only just virtual reality content, but any kind of interactive content. I mean, essentially, VR is a game. So anything that you can do in a game, you can use it to help present your products. So we'll see, for example, in Inventor, what formats are best used for 3ds Max, because we all know in Inventor, there's quite a few things that we can export it as, and we can also, if we want to, just import Inventor content directly. So there's a lot of options, and this does bring me to a point that we'll address in the course itself. So for better or for worse, we're still very early in the world of VR, and simple workflows have yet to be established. So that does mean that there is going to be a lot of, I won't say repetitive work, but you may not be able to keep all the work that you've done as you go from one software to another. So even just going from, let's say, one software to another, it's never guaranteed that we can basically keep all the data that we have. But now we're going through 3 different kinds of software. So again, there's now another chance for things to be lost. So, at this point, really, there's no well-established simple workflow for doing this. So that means that anyone that wants to get into VR may have to do some extra work of exploring and a bit of trial and error. But that's something, depending on your point of view, that could be a good thing and a bad thing. So, they do say that fortune favors the brave, and those trailblazers that can master it will have a distinct advantage over other people. So I highly suggest, if you haven't gotten into it, now is a great time to do it and stand out. So once we do that, we're going to go into, in the second course, into 3ds Max, and we'll take a look how we do things like the materials. So that is one thing that we will have to do. Unfortunately, because of the end goal of creating VR, we cannot keep the materials that we've done in Inventor. So they all have to be converted. So that's one, let's say, stumble into getting into VR. But that's just the way it is at the moment. So we'll take a look how to do the materials, anything else that we need to do to optimize this, because VR is essentially a video game. Everything is being calculated in real time. So it is dependent on the hardware that the viewer is using to view your content. So for example, if you want them to view it on something like a mobile phone, you may have to make more compromises than, for example, if they're using it on a high-end computer. So it's really at this stage in 3ds Max that you would be designing with intent for the final device that it's going to be viewed on. And then the last thing we'll take a look at is actually 3ds Max Interactive itself. So we'll see how to bring the content into this, create things like teleportation points. So for example, if you wanted the viewer to be able to jump into the cab of the front loader and see what it looks like from inside, you can easily make that happen. And I have a little video kind of showing what can be done. So in VR, what we have here is a controller that you can see. And if you've never done it before, it's fairly simple to navigate around. It's a combination of essentially either walking around in real life and also teleportation, because let's assume that the person that's actually viewing the VR content isn't in a giant empty room. They may have physical limitations like walls and tables and things of such. So to get around, it's really a combination of two different things. And it is a bit, let's say, strange or unfamiliar if you've never done it before. But once you've played around with it a bit, it's fairly simple. So you can see that I'm teleporting around, and the movement is actually all just done by my head. So if you've never seen content in VR before, I highly recommend you try to find a means to do it, because even in this video, it doesn't really come across. When you're in VR, you can actually finally feel how large this object is. This is something that you really can't get across in renders or drawings, blueprints, things like that. Like, I know, for example, from the drawing that it's 2 meters high, but you don't really feel it until you are in VR. And I really think that's one of the advantages in there. A lot of times I've had people, see or actually hold the final design. They go, oh, it's a lot smaller or a lot bigger than I thought. These are the things that you can't really get across unless you're doing it in VR. So it's a very interesting time that we're in. And, it's something that I highly recommend that people take advantage of if they can. So let's go back to the deck. By the way, the VR presentation that you will make, the final result will basically be a standalone executable that can be viewed by anyone, at least in this case, using Windows. So they don't necessarily need to have Inventor 3ds Max or 3ds Max Inventor, 3ds Max Interactive installed on their computer. They just need a Windows computer, generally with some decent hardware. That's something that you can always adjust, and that's it. So that's another, let's say, beauty of this workflow. So a couple other things I want to talk about, since you're getting your feet wet, so to speak, in 3ds Max. I don't want to take away any of the the shine from the rendering in Inventor or in Fusion. But since you are already in 3ds Max, you may want to take a look at using it also for doing the things that you see here. So again, these are from a design and manufacturing standpoint. These are a few of the advantages, I'll say, that you can have with 3ds Max. So really, it's more photorealistic rendering. To be honest, the rendering in Inventor and Fusion is quite good now, but there are still some, let's say, little details that really bring it, from that 90% all the way to 100%. And to be honest, really the final result, getting to that last, getting past or finishing that last 10% to get to 100% is not as simple as it may seem. Coming from the M&E world, when we want to create something and we want to give the feeling of size, it really is not just making sure that this object is 30 centimeters, or for example, this building is so many hundreds of meters tall. Just doing that isn't enough to give the viewer the impression of size. It's a lot of little details that your brain subconsciously sees. And these are things that you can do with the rendering in 3ds Max. So it's things like, for example, shadows. It may not be obvious, but for example, usually the smaller an object is, it casts smaller shadow. Sorry, not smaller, but softer shadows. Larger objects will cast sharper shadows. Also, things like the field of view will have an effect of the impression of size. I don't know if anyone knows about tilt shift photography. Basically, it's photography that makes whatever you're photographing look like a tiny model. And it's like I said, it's all those little subtleties that tricks your brain into thinking what the scale is of the scene. But not only that, there are some things like physicality-based materials. So really, if you wanted to represent the transparency, translucency, for example, how the light will bounce around when it's going through a semi-transparent surface. And even things like changing of colors based on angles. So you can see the car here has this pearlescent kind of look or iridescence to it. That's something that you can do with the rendering in 3ds Max. Another thing that I find useful is that 3ds Max does have a physics-based object and cloth animation. So let's say a practical example is that you have a design that's going to chop up pieces of plastic to, let's say, extrude into new plastic. So for example, for 3D printing, you want to make filament out of old prints that are no longer of use. You can show how the parts would interact with your design just by using the physics-based animation there. So you don't have to hand animate. You would just more or less drop, quote unquote, the parts in there, and then Max will calculate how everything would actually work around in there. And also things like cloth animation. So for example, industrial strip curtains, things like that, that can be all done in 3ds Max. And the last thing that I find quite useful is liquid simulation. So I did see a couple of years ago a wonderful presentation about additive manufacturing and basically creating molds. So for example, like plastic injection molding, how additive manufacturing can be done to create more complex paths for the coolant to flow in. And so with 3ds Max, there's liquid simulation, and then you can actually do a rendering showing that in your design, rather than, for example, let's say a series of dots or other means to try to show how the coolant or the fluid is flowing through your design. Then last thing, rendering. So if anyone has done rendering, and that also includes in Inventor and Fusion, it's generally a very long process. You hit render, you go get a cup of coffee, or you hit render, you go to sleep, and hopefully when you come back, it'll be done. With 3ds Max, you do have the advantage of doing network rendering. So that allows you to send render jobs to other computers that you have in your network. So this keeps your workstations free for work. So as you're working, you can just send a job and you know that it's being rendered. The other thing is that you can also use this technique to better use your resources for off hours. So let's say when everyone goes home for the day or for the weekend, what you can do is line up, hours worth of render jobs, and then when you come back, hopefully it's all done. So there's another advantage of using 3ds Max. So basically, take advantage of everything that you have available to you. And there you go. Anton?
Excellent. Ben, thank you so much for covering these advanced capabilities. Fantastic, phenomenal presentations, and we've got huge amount of questions. So if we didn't answer you immediately, then it means that we will post the answers in the forum post. I dropped the link in the chat, so we will answer all of the questions, that the ones that we don't have time for. Please look for the answer on the forum, but let's see how many we can cover right now. So before we go there, I wanted to share some of the, to make a recap of what we learned today, and then we'll finish the questions. So let me take the control back for a few seconds. Okay, so make a presenter. So can you see my screen now?
Yes.
Okay, so a quick recap, right? So everything or most of the things that we spoke about today, they're covered in the learning path about product visualization, right? I will send the link to this learning path in a second, but the bottom line, most of the things that we spoke about, the step-by-step instructions for how to do a lot of these things we spoke about in these courses. It's a learning path with 6 courses in it, and we will be adding more and more in the same learning path. This is the first thing. Second thing, that we have a lot of other courses available on other parts of mechanical design as a domain, not necessarily focused on certain products, right, but more focused on the outcomes or things that you try to do with the tools that you have access to, right? So take a look. They're all available in mechanical engineering discipline with your Autodesk account. So there is no need to pay. There is no need to register. You just use the same account that you use to access Autodesk software and go to forums. Okay, so let me drop the links in the chat so you can access this stuff. And let's cover some of the questions that we couldn't cover. The one that I'd like to ask Ben about is the kind of the opposite workflow from 3ds Max to Inventor. So do you see it often, Anil and Ben, do you guys see a good way to import back the more freeform organic shapes done in 3ds Max to Inventor, and are there any best practices around that?
Basically, no. I don't hate to kind of shut this down, but because 3ds Max is primarily a mesh-based editing software, whereas Inventor are solid bodies, there's really no easy way, let's say, to bring it in. I do see to a certain degree, let's say with Fusion, because there is a little bit more in terms of mesh-based editing in there, that's a possibility. But yeah, I've actually received this question for years off and on, and to be honest, it's not an area I would actually consider trying to look into. Unfortunately, it's
Anton?
just the way that it works. Yep, someone?
Hi, Anton. This is Tom. One thing I would throw out there is that the freeform modeling, the sub-D modeling that's in Fusion is also an Inventor. There's slightly different flavors of each of the tools, but for the person who is looking to create the type of form that they would desire to make with sub-D and 3ds Max and bring over to Inventor, one thing they might want to do is explore the freeform tools that are in Inventor as well.
Yeah, that makes sense. That makes sense. So again, two solutions, either to the sub-div modeling in Inventor or Fusion, or you can still use the third-party formats such as SAT or OBJ to import to Inventor. Also, we had the questions about the kind of the retired products showcase, and people who have long history with Autodesk, of course, remember those cool products that we have. There is a current alternative to Showcase, which is more up-to-date, more powerful, called VRAD, right? The reason why we did not cover it today, because it's a separate entitlement, right? So very often users of product design and manufacturing collection will have to pay separately for VRAD. That's why we didn't cover it today. But I mean, it's a great option. That's a hugely powerful tool. So check it out. There are some incredible things that you can do with VRAD, and it's been widely used in automotive industry, for example. So there are quite a few questions that we couldn't answer. So we will answer them in the forum thread, and also you will receive the recording of this webinar on YouTube in a couple of days. So on also in the comments of the YouTube, we will drop the link where we address the remaining questions. So our apologies that we couldn't answer all of the questions today, but I hope that the information provided is useful. Watch the recording, take a look at those courses, and more importantly, just try to do some of those things that you didn't do before. And don't forget to register to the next virtual meetup in August. So see you all, and thanks again to all of you for joining, and to our wonderful speakers for their presentations. Huge thanks to all.